is up, everybody? What is up, everybody? What's up, everybody? This video is going to cover USACO's 2018 December contest at the bronze level. Problem number 1, mixing milk. Farming is a competitive business, particularly milk production. Farmer John figures that if he doesn't innovate in his milk production methods, his dairy business could get creamed. Fortunately, Farmer John has a good idea. His 3 prized dairy cows, Bessie, Elsie, and Mildred, each produce milk with a slightly different taste. And he plans to mix these together to get the perfect blend of flavors. To mix these 3 different milks, he takes 3 buckets containing milk from the 3 cows. The buckets may have different sizes, may not be completely full. He then pours bucket 1 into bucket 2, and then bucket 2 into bucket 3, and then bucket 3 into bucket 1, and then bucket 1 into bucket 2, and so on in a cyclic fashion for a total of 100 pour operations. So the 100th pour would be from bucket 1 into bucket 2. Okay, so let me just draw a picture here. So we got buckets 1, 2, and 3. There's going to be some milk potentially in each of them. They may or may not be full, and we don't know for certain, I guess until we read the data, obviously, whether or not all the milk is going to fit. So we're going to be pouring from bucket 1 to bucket 2, but it's possible that after pouring, some of the milk's going to be left over, because if the amount of milk in this bucket is more than the empty space in that bucket, obviously you can't pour all the milk in or it would overflow. So you pour all of it if possible, stopping if there's any left and leaving it behind. We're going to go from bucket 1 to bucket 2 to bucket 3, bucket 3 back to number 1, 1 to 2, 2 to 3, 3 back to 1, and we're going to do that over and over 100 times, with the last one being from 1 to 2. And if you think about that, that makes sense, because your first pour is going to go from 1 to 2, second from 2 to 3, third will go back to 1, and then every 3 pours, 1, 2, 3 goes back to bucket 1. So what's going to happen is you're going to do each of those pours 33 times. So 33 cycles essentially, from 1 to 2, from 2 to 3, from 3 to 1, because 33 times 3 pours is going to be 99, and then one last pour from bucket 1 to bucket 2, ending on bucket 2. So that's how then that's going to be plus 1 equals 100. So that's how the math is working out there. Because it takes 3 pours to go in a cycle, essentially what you're going to do is you're going to do the full cycle 33 times, and then 1 extra pour ending in bucket 2. When Farmer John pours from bucket A into bucket B, he pours as much milk as possible until either bucket A becomes empty or bucket B becomes full. Please tell Farmer John how much milk will be in each bucket after he finishes all 100 pours. So that's all you have to do. You're going to do 33 cycles where you pour from bucket 1 to bucket 2 to bucket 3, and bucket 3 to bucket 1. Once you finish 33 cycles, you do 1 additional pour from bucket 1 to bucket 2. And in each time you do the pour, you're just making sure that the buckets don't overfill. And obviously, if the bucket doesn't have enough to fill the one, you can't just go directly to filling it. So they're not pulling any punches here. There's nothing fancy. It's 3 buckets. It's 100 pours. You can completely simulate this and brute force this, and you have more than enough time to finish it. If you were so inclined, you could probably do 100 if statements and just write a single stack of 100 if statements. If you're feeling clever, you can put that into a for loop and do 33 cycles. You can try and get an array involved if you want to do that, or get functions involved, but you really don't need to do anything especially fancy for this one. So we'll look at a couple different ways we can lay this out to kind of have a smart solution to it. But as far as just solving the problem, again, there's nothing really, there's no weird algorithms or weird tricks involved in this. It's just like direct simulation. Okay, input format comes from the file called mixedmilk.in. The first line of the input file contains 2 space separated integers. The capacity, it's a lot of S sounds, capacity C1 of the first bucket. Okay, so this is the first bucket. 2 space separated integers with the capacity C1 of the first bucket. So first bucket's capacity is 10, and the amount of milk M1 in the first bucket, which is 3. So what that tells us is the bucket size is 10. It has 3 gallons of milk in it. Both C1 and M1 are positive, and at most 1 billion. 1 billion is 1 0 0 0 0 0 0 0 0 0. 1 billion. The reason they're pointing that out is because if it went more than about 2.1 billion, you get out of the range of an integer. Integers, when you do, like if you're working in Java or C++, you do int x. The largest value that can hold is about 2.1 billion. So sometimes that will come up in these problems where you have to use a different data type other than an integer. In this one, what they're specifying is because it's at most 1 billion, you don't have to do anything fancy. So they're just making sure that you're aware that you don't need to do anything fancy for that integer limit if you happen to be even aware the integer limit exists. So if you do happen to know the integer limit exists, they're telling you specifically. A lot of people don't even really know that information. It's important to realize this though, because there are going to be problems. You typically run into them more at the silver level where 2.1 billion isn't going to be large enough. And when that happens, they usually will tell you directly in the problem that you need to use a long data type. But we won't have to do that for this problem. This problem is very straightforward and they're not doing anything fancy. Okay, best billion, second and third lines of similar containing capacity of milk for the second and third buckets, right? So I have first bucket with a size of 10 in this example case. Second bucket has a size of 11. Third bucket has a size of 12. First bucket has 3 gallons, and then that doesn't look like a 3, and then 4 gallons, and then this one has 5 gallons. So what's going to happen is, and then the output is to print 3 lines of output, giving the final amount of milk of each bucket after 100 pours. So after 100 pours, this is where they're expecting it to be. So we're just going to kind of go through a couple of these. I'm not going to do all 100 pours. You'll go from this one to this one. I have 11 minus 4, which is 7. I have 7 gallons of empty space in this bucket. I only have 3 gallons to pour, so I check to make sure that's enough. Because there's enough space for it, I'm going to add that 3 gallons in, which is going to leave this bucket empty. Second pour is going to go from this bucket to this bucket. I have to add in 4 and 3, which is 7. This bucket has 12 minus 5, which is 8 available space. So we're going to be able to pour all of that milk into this bucket. We're going to have 5, 4, and 3. Which is, what is that, 11? 9, 10, 11, yeah, okay, no, 12, I can add. 12, okay, so that one's completely full then, right, 5, yeah, and so it all fits in the last one. Okay, so we're able to fit all of them in the last bucket. That's not necessarily a guarantee, it depends on the problem. We then pour back to the, I lost a gallon in here somewhere. 10 and 2, 5, 6, 7, 8, 9, 10, 11, 12, yeah, that is 12, 5, 7, 12. Yeah, okay. No, we're good. Thought I lost a gallon. Okay, so we've got 12 in this bucket. We pour it back to the first one. That's going to fill all the way up to the top with 10 gallons of milk, leaving behind only 2 gallons. 2 gallons. I'm living proof you don't have to be good at math in order to do these. Okay, so I got 2 gallons left behind, and I got 10 gallons into here. We're going to pour the 10 gallons into here, 10. And then that's going to be empty again because that'll fit into 11. Pour the 10 gallons into here again. That'll be full up to the top. And in this particular problem, we've noticed a pattern because we've got enough space to move this 10 gallons around in a circle. So it's just going to keep doing that, 10 gallons to here, 10 gallons to here, and so forth. And it says the final pour is going to end on the second bucket. So then your last output here would be 0 gallons in the first bucket, 10 in the second one, because that's where that last pour of 10 went, and then only 2 left in the third one, and that's your output. That pattern, again, is not necessarily going to be the case. That only happened because we were able to get all of the milk into the final bucket. If the final bucket was smaller, then the amount of milk that we had cumulatively, for example, let's do a couple other examples here. If I have like a 5-gallon bucket, let's do 3 5-gallon buckets. Let's do 5, 6, 7, just to change it up. 5, 6, 7. If I were to have 4 gallons in this first bucket to start with, and 5 gallons in this bucket. Let's just talk about how that would work. Let's do 4, or I did 5. This one liter, 5, 6, and 7 gallon buckets. This one has 4 in it. This one has 5 in it. We'll make this one with 6 in it just for giggles. 6. Okay. So what's going to happen here is I've got 4 gallons in this first bucket. When I go to pour into the second bucket, I only have 1 gallon of space here because 6 minus 1 is 5. So that 1 gallon is going to fit into here, which is going to leave 3 gallons behind. And you are going to have situations where this occurs. So now this will be full up to 6. Then we're going to try and pour from the second bucket to the third bucket. That's going to go up to adding 1 gallon, which is going to take 1 gallon away from here, dropping that back down to 5. And then this is going to be up to 7. Then when you pour back to the first bucket, we'll be able to get 2 gallons out of that second bucket. 2 gallons, 2, that's going to leave 5 behind. Make sure we didn't accumulate any milk. Yeah, we're still good. So it's still 4, 5, and 6. So we had 2 pour back into here. So now this first bucket's full. because there was only one available. Yeah, I only had one available in each one. Okay, so only 1 gallon of that is going to fit to here. 1 gallon to there, which is going to leave this one at 4 out of 5 because 1 gallon pours over. We're going to pour into this next one. 2 gallons are going to come out of here, which is going to drop this one down to 4. And that's going to be full again. And then I'm only going to be able to pour 1 gallon back. It's going to drop that down to 1. And that'll be +1 is full again. 2 gallons are going to pour over, which is going to drop this down to 3. Let's do 2. And we had 1 gallon available, so that's going to drop down to 1. So it is kind of making a pattern here. I'm not writing down the numbers as I go, and then that's going to be full again. I'm not writing down the numbers as I go, but we keep alternating the volumes of the 5th and the 6th. So I don't think there's going to be any sort of shortcuts where you go, 2 cycles in and then figure out what the pattern is, because I think the pattern actually can oscillate. So anyway, it's just suffice to do essentially a brute force on this. So the way a brute force essentially is going to work is most likely you're going to have some sort of a for loop. It'll go from 0 to 33. And you're going to just calculate how much, and again, you can have 3 if statements. There's no reason to do anything fancy here. Calculate how much it would take to pour from bucket 1 to bucket 2. So if you've got like bucket 1 and capacity 1, bucket 2, capacity 2, bucket 3, capacity 3, then essentially when you're going from bucket 1 to bucket 2, the amount of space you maximum can have is going to be the difference between capacity 2 minus the current amount in bucket 2. I need to figure out what's smaller between that and what's in bucket 1. Because if bucket 1 has 2 gallons in it, and this bucket's like totally empty, it's like a 10-gallon empty bucket, then we're only going to be able to pour 2 gallons. If our capacity was 10 and the amount of milk in bucket 2 was 0, we'd have there'd be like a full empty or an empty container with all that empty space. And so then if we only had 2 gallons in bucket 1, we'd be able to put that all in. But if this bucket is quite full, the second bucket is quite full, like 9, and I've got 5 gallons in here, then I need to get the difference between the capacity of the second bucket and the current amount in the second bucket, which is 1. And that 1 versus in this bucket 1, I've got 5 gallons means I can only pour 1 gallon. So that's the first step, is just figuring out what your difference is, what your minimum is between the difference of your capacity and the current amount in destination bucket versus the amount just in the first bucket. Once you figure out the min of that, you basically do bucket 1 minus that, minus equal that min, and then bucket 2 plus equal that min. That's all there is. So you figure out whatever the smallest amount is. This will work with empty buckets. It'll work with if your destination bucket is full, then it would be like 10 minus 10, and then you'd still have a 0. If bucket 1 didn't have any milk in it, it would be a 0. And either way, your min is going to come up with whatever the smallest amount is. So even if the minimum is 0, you'd be adding 0 and subtracting 0. It's not going to break anything. That transfers from bucket 1 to bucket 2, and then you just repeat the process with bucket 2 to bucket 3 and bucket 3 to bucket 1. If you want, you can have 3 mins in a row. Min of C3 minus B2, comma, B2, comma, B3 rather, comma B2. And then you can do the next 3, would be bucket 2 minus equals and bucket 3 plus equals. And then it cycles back to bucket 1. You could do that. If you wanted to make a function, depending on what language you're using, if you're in C++, you can do pass by reference. Or in Java or Python, you can have static variables or global variables or whatever, and just have the buckets and the capacities access in global space. And then you could call a function, and then just specify, what your starting bucket is, what your ending bucket is. You'd only really be able to do that with pass by reference. Now that I think about that, the only way you would do that in Python or in Java, you'd have to put them in an array. And then pass a reference to the array, because I don't think we have the ability, we have no way to pass an integer by reference in either of those languages. You'd have to build some sort of a class. It would be messy. So yeah, the easiest way to do it would be essentially to again, the easiest way to do it would just be to have 3 if statements with 3 mins. You don't even really need an if statement if you're using a min, but basically you just need to figure out what's smaller between the difference in the destination bucket and the amount of milk that you're pouring from, and then just move that from the first bucket to the second bucket. And again, if you wanted to use an array, you could have 2 arrays, maybe like a capacity array would have 3 items in it, 1, 2, 3, and then the current amount, maybe volume array would have the amount in it, 1, 2, 3, and then if you wanted to, you could use I, and then I plus 1 modulus 3. if you want to be fancy, and then you could just loop through this 100 times. So what you do is you have a for loop that goes from 0 to 100, or I guess 99 if you want to include it. It's including 99 and then not 100. Have the for loop go from 0 to 100. You can get bucket one index, or I guess bucket source index would be I modulus 3. Bucket destination index would be I plus 1 modulus 3. So then when I is 0, then your bucket one index would be 0, and the second one would be 1. When I is 1, then you get 1 and 2. When I is 2, you'd get 2 and then back to bucket 0. And then when I is 4, you're back to 1 and 2 again, or 0 and 1 again, sorry. And then 1 and 2, 0 and 1. So if you want to use a for loop, and again, this is a fancier approach, but if you want to use a for loop, you can use that plus some modulus to get the indexes, and then use arrays. If you're using an array in Java, you can just pass the array if you want to. It'll always pass it as a memory pointer, so you don't have to worry about that. If you change the array in the function, it'll change it. I mean, that will change the array permanently. For C++, you might have to use memory pointers for that, or just make it global if you want to keep it simple. Python, I think it's also going to be shared. So if you pass an array to a function and change it in that function, it'll update the actual array back in the main section. That's more of a question on scope. And so this is something that's kind of important to be aware of if you are going to use functions. I'm just going to kind of briefly run through the languages. If you are going to use functions, one thing that's important is to be aware of how scope works. If you pass an integer to a function, like if I have f of x, and then in that I say x equals 7, and if I down in the main section, I have something like x equals 3, and then call f of x, then if I print x, I'm still going to get 3. And the reason why, and this is how it's going to be in any language except for specifically in C++ if you do pass by reference. The reason why that's happening is because when you create this new variable x up here, when you call the function, that's actually creating a new variable, which also is called x, but it's creating a new variable in a different frame of reference, and it's setting the value of that variable to 3. When you change that variable to 7, that doesn't affect what's happening down here in the main, with the exception that in C++, if you throw an ampersand in front of the variable, you do a pass by reference. If you do pass by reference, then instead of creating a new variable, you get the memory address of the existing variable, and you link the new variable to the memory address of the existing variable when you do pass by reference. And then when you mess around with the variable up here, that's permanently changing the variable down in the main. In order to get around that, if you don't want to have to mess with passing by reference, a lot of times what people do is they make things global. So like up the top, and we're talking about C++ here. Up at the top, they'll do like int x. And then when they refer to the function, they don't pass the variable at all. It's just implicit that when you call the function is going to access the x in the global frame. And then when you do the function down here, you'd be only passing the indexes and not actually, so it'd be like index 0 to index 1 or whatever. You would pass those here, but then your array would be up here and you'd be able to access it. So in the case of an array, with C++, you probably just want to declare it in global space. With Java, you may want to just make it static. But with Java, you can pass a primitive array to a function, and if you change it in the function, that change will stick. Whereas with C++, I'm pretty sure it makes a copy. I'd have to double check that. But I'm pretty sure it makes a copy of the array. So then if you do changes to the copy of the array, it doesn't change anything. It certainly does that with vectors. If you pass a vector to a function in C++ and change it inside the function, that vector doesn't change in the main. Whereas if you're using a primitive array or an array list in Java and you pass it to a function and change it, that change is permanent. And that just has to do with how memory management works in C++. But that's just something to watch out for. If you create the variables up the top as global variables, then again, you don't have to think about it. But just do be aware that when you're passing a vector in C++ or passing an array in C++, it's not going to be the same rules as when you're passing an integer necessarily, in terms of like whether or not it's making a copy or whether or not it's passing as a memory pointer. In C++, it's pretty much always going to make a copy. In Java, it pretty much is always going to pass a memory pointer. But in C++, you do have the choice to use the ampersand to pass by reference. So again, that's something that maybe I'll have to do a video and go into detail on that because it's a bit much for this problem. But anyway, getting back to the original problem, you've got some sort of a loop. Again, you want to run it either 0 to 100, or if you want to do it the simple way, you run it 0 to 33, and then figure out some way to pass. If you're doing the 0 to 100 version, then you just use modulus math to figure out your index, and then figure out a way to have an array or a vector that you can mess with. And then if you want to do it the easier way, you have your for loop go from 0 to 33, and then you just have 3 separate blocks of code, one for moving from bucket 1 to 2, one for bucket 2 to bucket 3, and one from 3 to 1. I mean, that's the like easiest way to do it if you just want to keep it simple. And that's the problem. So good luck coding it, and I will talk to you in the next one.